The last section of Unit 2 that we want to cover is linear inequalities. When we're looking at inequalities, we're looking at essentially things that look like equations but contain one of these four symbols instead of an equal sign. These are read as less than, greater than, less than or equal to if it has the line under it, or greater than or equal to if it has the line under it. We're going to solve these as if it were an equation with an equal sign. We're going to try to get the x by itself. For simplicity's sake, when we do these, we always want to get the variable on the left side because they become easier to graph, which we're going to look at later on in this section. We want to graph these inequalities, and they're a lot easier to graph if the variable is on the left to begin with. Otherwise, you have to worry about flipping the sign when you go to graph it. As we're solving these near the end of the problem, if we're multiplying or dividing both sides of the inequality, that should say, by a negative number, you reverse the direction of the inequality sign. And we'll see some examples of that as we go through this, but that's a very important thing to note. Anytime we multiply or divide by a negative, the sign gets flipped. When we do graph these, less than or greater than, no line under it, you use an open circle because that means we do not include the end point. Since it's strictly less than, say, 4, then I don't want to include 4 because 4 is not less than itself. So I use an open circle to show that I'm doing that. If we're graphing and it has or equal to under either one, then we use a closed circle to show that we do include the endpoint. So if we're greater than or equal to 4, we could be 4, so we want to include that, and then everything greater than. And again, you'll see these as we move through this in action. It just makes a little more sense. Another way to write an inequality is in interval notation. I'm going to move this calculator out of the way a bit. Parentheses mean not included, so that's the same thing as a less than or a greater than. Brackets mean included, so that means less than or equal to, greater than or equal to. So we read this, and I'm going to fix that here. I can get out of my pen. No, that's not what I want to do either. Never mind. Anyway, this is read every number from A to B, not including B, and the other is read, the one with the brackets is read, there we go, every number from A to B, including A and B, because there's a bracket on both sides of this one. Sometimes we'll have a bracket on one side and a parenthesis on the other. So the parenthesis is on the side in which we do not include the endpoint. The bracket is on the side in which we do include the endpoint. And again, these will become more clear as we work through them. So let's start off just solving some of these. So again, we want to get the variable on the left side, and we want to solve them like it was an equation. So essentially what I want to do in this x minus 6 is greater than negative 11. I want to get rid of the minus 6. And that happened again. So I'm going to add 6 to both sides. So I get x is greater than negative 5. Now I'm going to graph it and write it in interval notation also. We graph these on a number line. 2, 3, 4, 5. There's negative 5. So since I want to look at everything strictly greater than negative 5, there's no or equal to here, so I know I'm going to put an open circle at negative 5, and I'm going to change my pen color real quick. Open circle at negative 5, and everything to the right, because everything to the right of -5 on a number line is greater than -5. I want to write this as an interval, so I look at my graph. My graph starts on the left-hand side at -5, so I'm going to start at -5, and then I'm going to go on to infinity because it goes to the right forever, so I use the infinity symbol. In my open math, you'll use 2 lowercase o's to make infinity as you type it. Now, interval notation always gets a grouping symbol, parentheses or brackets, or one of each around it. So in this case, infinity we never hit. So infinity gets a parenthesis no matter what goes on the other side. -5, since we're strictly greater than, we're not including the endpoint. We have an open circle here, so that means I know I get a parenthesis. So my interval notation is parenthesis on both sides, -5 to infinity. We're going to look at one in which we have to deal with a negative. Negative 2x is less than 14. If I was solving this for x, I would divide both sides by -2. I'll switch back to black so I can draw my line out here. And I'll switch back to red to finish solving it. So when I divide this by a negative, this step here, I must flip the inequality symbol. And that happens every time I multiply or divide by a negative. Here I'm dividing by a negative, so I have to flip it from less than to greater than. 14 divided by -2 is -7, so I'm looking at x is greater than -7. So open circle at -7 and everything greater, so everything to the right. And my open math software, you just choose open circle or closed circle, click the start point, and then move your mouse all the way to the right to go to the right forever, to give you this arrow at the end. So now my interval notation, again I'm starting at -7 on the left, parentheses since I am strictly greater than, and then going to infinity. So I'm going to solve this for x again. -3x plus 11 is less than or equal to -13. I want to get rid of the plus 11, so I'm going to subtract 11 from both sides. Get -3x is less than or equal to -24. Now notice I subtracted 11 here. I did not flip the inequality symbol because I did not multiply or divide by a negative. I simply subtracted. So now I need to divide by -3, which means I am going to flip the inequality symbol. -24 divided by -3 is 8. I want to graph this. 8 is somewhere over there. So this time I have an or equal to, so I want to include the 8. So I'm going to have a closed circle at 8. Greater than is everything to the right. So I start at 8 with a bracket this time because I included it. Closed circle and bracket mean the same thing, include the endpoint. And then I go to the right forever, so I'm going to infinity. Infinity always gets a parenthesis. So there is no bracket on infinities ever, even if there's a bracket on the number. Here I have a little more work to do in part D. First thing I need to do here is distribute my -4 through the parentheses. -4 times x, -4x, -4 times 1 is -4. I want to get all my variables on the left hand side, so I want to move this -4x by adding 4x to both sides. That effectively gets rid of every x on the right. -6x plus 4x is -2x. Keep the -3, keep the greater than, keep the -4. Get rid of the -3. I'm going to add 3 to both sides. Leaves me with -1. Lastly, I'm going to divide by -2. Again, I'm dividing by a negative, so I'm going to flip the inequality sign. So I get x is less than 1/2. So there's 1/2. You probably won't see very many fractions on these just because the graphs look better when they're whole numbers. Less than, so we do not include the endpoint. Less than is everything smaller, everything to the left on the number line. So now we're going to write that as an interval. So this time we're going to infinity in the negative direction. So we say we're going to start at negative infinity and then we're going to end at 1/2. Don't include the 1/2, so we use a parenthesis there. Now we have two inequality symbols in one inequality. This is called a compound inequality, and what we try to do in this case, up till now we've been trying to get the variable on the left hand side, but here we want to keep the variable in the middle when we have two inequality symbols. So we're going to keep it in the middle. We're going to get it by itself in the middle, but we're going to keep it in the middle. So I want to get rid of the plus 1, so I'm going to subtract 1. But that means I need to subtract 1 from every other part of this inequality. Since I have two inequality symbols, that means there's two more pieces to this, the far left-hand side and the far right-hand side. That gets rid of the plus 1 in the middle, so I'm left with just the x. Negative 4 minus 1 is negative 5. 8 minus 1 is 7. Now what that says is x is between negative 5 and 7. Include the 7 since we have an inequality symbol there that has an or equal to on it. So when I go to graph this, negative 5 somewhere to the left of 0, 7 somewhere to the right. I don't want to include the 5 because there's no or equal to on the side in which the 5 is contained. So I'm going to open circle at the 5. The side with the 7 does get a closed circle because we do want to include it because it does have the or equal. So now this one has an endpoint on both ends. We're not going to infinity. We're just shading everything between negative 7 and 5. Now keep the open circle on the negative 5, closed circle on the 7 because of their respective inequality symbols. When I write this as an inequality, I start at negative 5 and I go to 7, always go left to right. And since I had an open circle here, I didn't include the negative 5, it gets a parenthesis. Had a closed circle on the 7, so it gets a bracket. So there's your interval notation for that, negative 5 to 7, parenthesis on the negative 5, bracket on the 7.